Hey, what's up guys? I've spent for about 5 hours on debugging the current web scraping project I'm now working on for one of my clients, and we're scraping the homegate.ch, which is a Switzerland-based real estate property site, and we're going through first all the commercials, then all the residential properties, and then going recursively to scrape data from every listing, from every corresponding listing. And here is one of the cards, one of the advertisements we're extracting data from, and it will consider like main information, features and furnishings, descriptions, like coordinates like latitude, longitude, price, address, and all the stuff. Those are quite pretty trivial to extract, because here at the very end of the source file we're having the scrape tag containing all the information in JavaScript variables. So I just did get rid of this part of string within the script, and then parse the entire stuff to the Python dictionary, and eventually did extract the image URLs like agents, agent information like phones, emails, addresses, not only agents but all the information that is needed has been extracted from here. But my client has discovered that the costs are not available in the output files in the scrapers that I've provided. That's the reason why I need to create some I needed to create some custom DOM element selectors. And this when I'm looking at this, when I've already completed this task, it seems to me quite pretty trivial, but it really took me lots of time to discover the right approach of how exactly to proceed in order to create the decent data extraction logic. So in this video I'd like to share the end result of what I've got basically, and we'll be extracting data from 2 pages from this one, where the format is like this, and from this one where there are kind of less of data, and also instead of the price we have this string like by request. So this would be slightly different to deal with. And also let me show you in the inspected elements. So first I was trying to extract data from this div data v blah blah blah, which is the attribute with no particular value being assigned to it. But later on I realized the costs actually can be extracted from this div data test that has the costs value here, and then this dl, dt, and dd tags are having the corresponding information. And also the one little more challenge here is that these guys are kind of 1 elements, so the length of these guys would be 3, and of this it would be 6, because the CHF is appended to each particular value here. So we will need to get rid of that, and then dynamically append this when creating the element. And at the very end, the structure of what we want to obtain would be actually like the list, and the first line would be this, and then this, and then this line. Not in the format of Python dictionary, as you might be wondering, but instead the list, because it's kind of more appropriate way for my client to consider this data in this sort of a format. So that's kind of the request. So I need to make exactly what I'm asked to do basically. So if you're interested, let's actually start working on this little task, and at the very end we'll have the code that will be extracting the costs from this kind of listing pages. So first we need to obtain the HTML source codes for the particular URLs. And as far as I'm not going to create a full-blown Scrapy spider, by the way, the project all is done using this Python Scrapy framework, so I'll use the request library just to obtain the Unicode characters free responses into the HTML stored locally, and then I'll be using the SCRAPY selectors to actually create the data extraction logic for this sort of data. So if you're interested, let's actually start writing some code. So first we need to store HTML locally like this. So we'll be dealing with the 2 links. I just copy this one, so let's call this URL 1 equals to this one, and URL2 would be equal to this one. So just copy and paste. So you probably can make them a list. So the URLs will be like this, and also just to well, probably could have made it even a list of dictionaries just to store the response in a single loop. So we'll be having the two elements, so like the URL and okay, like this, and file name as well, like file name, and this would be response1 HTML, and this respectively would be file name response2.html, and save. Okay, and now we need to loop over this kind of element. So say, well, let's call this URLs instead. Save. So this URLs and file names data structure. Okay, and here we're actually, yeah, so here we store HTML locally, so we need to loop over these URLs and the file names at the same time. So we can simply say like for URL in URLs, and okay, so we'll be making use of okay, so response, oh, let me first just try to print. So we just print the URL and say Python 3 and selector.by what? Invalid syntax. Okay, because I forgot to put a comma here. File name is not defined. Oh, maybe. Sorry, yeah, it's not JavaScript, of course. It's not a JavaScript. Okay. So, okay. So now respectively we can say URL and URL file name using the keys just to obtain the distant data. So we need to create a response object that would be equal to, okay, we need to also import requests here. So here we got the packages, so import requests, save requests, get, and URL, and the URL, and we say with open, and here we're using actually URL file name to write to the particular file name. We want to write the file stream and as file here and say f.write response.text, and I really hope to obtain 2 HTML files as the result of this script working. Okay, so here we got 2 responses, which is really great, and now let me just comment this stuff out because we don't really need this anymore until the end of this video. So now we can simply start opening our files. Well, I will just change in 1 to 2 just to show you the difference between the data being presented on this page here compared to the data on this page over here. So also we'll need to import the SCRAPY selectors in order to work with them, basically because as mentioned, as I was already mentioning, the project is done using SCRAPY framework, so I can simply say from SCRAPY selector import selector like this, and here we'll define the HTML content variables. So the content for now would be the empty string, and now we need to read local HTML file, and here we can simply say with open response1.html we want to read the file string as file, and for line in app.read we need to say content plus equals line to populate the content variable with the content of the actual file here. And let's first try to print our content to make sure it contains the valid HTML response. No such file directory. Oh my god. Why did I use... Oh, the dot instead of comma should have been there, but I just fixed this. You know, I'll be cheating here slightly a bit. Okay, so let's try this one more time. Okay, we got the reasonable HTML response, pretty valid one. So now we can work with this. So now we need to init SCRAPY selector, and I'll be using the response variable, which is quite pretty trivial name for naming the variables of the response object within the SCRAPY callback function that is fired after the request has been completed, basically. So here we can simply say selector and the text equals the content, and if we just now try to print our response, then we'll see the selector object, the SCRAPY specific selector object, which is basically really nice. And from now on we can actually start creating our data extraction logic here. So what do we need now? So let's try to inspect. Okay, we already did inspect that, so we're looking now for this sort of an element. So we're looking for one more thing to consider. So I'll call the variables calls dt and calls dd accordingly to distinguish between the key names and the corresponding values. So let's create the costs dt, that would be equal to response dot css. I'm using the css selectors. I prefer them over the XPath selectors when dealing with the SCRAPY. Well, that's personal. My personal opinion. I'm not saying that CSS is better, but okay. And here we say div, and as far as we're dealing with the attribute name, not with the class name, we need to enclose this within the square brackets. Also, we don't need this quotes, because the format like this is just barely enough. And within this element, we're actually looking for this dt and dd elements, and actually all the nested text within them. So if I just simply say find recursively like css, and we're looking for dt, all the text. So this star stands for trying to obtain the text from the child elements. Whatever the child elements this tag contains, all the text would be extracted accordingly. So here we also need to specify the get all. Now let's try to print our costs dt. Okay, so let's try to run this. Okay, so we have net rent, expenses, and rent, which is great. And also we'll need to make exactly the same but for the dd tags. So this time we'll be making use of the dd tags, and let's try to bring them as well. So here we got what I've been talking about. So the length of this list is twice more compared to this one, but as far as we're supposed to be looping over the indexes and taking the length of the element as a kind of constant, then we need to make the length of these two lists absolutely the same. So we need to get rid of this CHF, which stands probably for the Switzerland local currency, I'm not sure. And I'll be using the list comprehension technique in order to achieve removing these CHFs from the list. So I can simply say here like so. I'm closing the entire variable into the square brackets to convert this to the list, and now I can say like let's call this F for the feature, or maybe just element is better. So element for element in, and we need to use only those that satisfies the condition if CHF if element is not equal to CHF. Now let's try to see. Okay, so now we did successfully remove these CHFs, and well, also we can probably try to strip this as well. Well, yeah, I can just strip the element to get rid of those extra spaces. Okay, great. So from now on, what we can actually do, we can create a variable, costs, of course. Costs, which would be the type of Python list. So this would be our data structure. And here we need to loop over costs indexes range. So I can simply say for index in range from 0 to the length of whatever costs dd or dd, because the length of them is literally the same. Well, let's consider the first one, costs dt, and here we need to say costs dot append, and here we're using costs dt indexed by the index plus so we need to, okay, let's just consider the empty space for a while, but later on we'll add CHFs there. Costs plus costs dd indexed by index as well, and let's try to print basically our costs here. So okay, now we have net rent and this value, add little expenses and this one, so it's absolutely the same like we got on the site, which is great. Okay, so but we don't yet have the CHFs, and they are all the same all along the way, so that's the reason why we can actually append those CHFs like this, and finally we'll get this kind of sort of data structure. But if we just consider response to HTML instead of response 1, then the little disaster is happening. So you see like CHF by request, so it just appends this CHF to non-integer value basically. So we just have a look at the corresponding page over here, see like this by request. So we need to handle that condition as well. So we can simply say if, and we're referencing costs, costs dd index. So if this index equals to by request, well, in this case we need to say just simply copy paste and like this. So we're not appending this CHF, not concatenating that, else just what we had before. So again, so now we have rent by request, which is fine, and we just go again for this the very first file initial. So now we have the CHFs being appended. Well guys, I know this might look really trivial, and it is basically. And I know why it took me so long, but you know, like web scraping is not really that difficult at all. In essence, the web scraping is really trivial because you just need to extract the data. That's kind of it. But due to the sites being malformed and the DOM elements are not well structured, it often happens that some issues arise along the development process, and especially along the process of creating data extraction logic. So it takes quite a bit of time to actually using the trial and error method, by using the trial and error method to obtain the correct way of how to go and how to proceed with creating that data extraction logic. So I hope you learned something interesting out of this tutorial, and I hope this would help you to save much time during working on your web scraping projects. I wish you all the best, guys. So until next time, and take care.